Previously on Chemistry Z, our heroes discovered the dot and cross diagrams of the 8 simple covalent molecules that you need to learn from the ancient syllabus. And within that covalent cave, they were able to uncover why simple covalent molecules have low boiling points. And now, our heroes have reached the mighty giants of the covalent molecules. Will our heroes be able to pattern the knowledge of graphite, diamond and graphene? Find out in today's episode of Chemistry Z. Here are the retrieval questions for this lesson. You know what to do. Intermolecular forces break when a substance boils and when it melts. The boiling point of group 0 elements increases as you go down the group. Alkali metals get more reactive as you move down the group. In the last lesson, we saw that covalent bonds are when atoms share electrons. This can be represented using dot and cross diagrams, displayed formulas, or ball and stick diagrams. The chemical shown here is methane.
I swear that's what cows produce.
Yes, they do, and some humans produce this as well, which is one of the reasons that some farts can turn into flamethrowers. Methane and other small molecules are simple covalent, and they contain a limited number of atoms held by covalent bonds. And due to their weak intermolecular forces, they have low boiling points. Check out my previous video for more information on those weak forces. Giant covalent structures are different. You have bare atoms held in a 3D structure by strong covalent bonds. You need to be able to recognize these 3 on sight: diamond, silicon dioxide aka silica, and graphite. You lot know that I love the origin of words. The metal that Wolverine is made from is adamantium, which is another spelling for the Greek word adamas, which meant unbreakable. This is where diamond gets its name from, but we just dropped the A. This is also why when we have someone that's strong-minded, we say that they're adamant about something. This name suits diamond because it's the hardest naturally occurring substance that we know. It is pretty easy to recognize graphite when you see it, but you have to look a little bit more careful for diamond and silica. All the atoms in diamonds are the same, and we can see that because you've just got one color and one size. But we see 2 different types of atoms in silica. This helps us distinguish that we've got 2 different atoms there. So the way to tell the difference between diamond and silica, the one that has 2 different atoms, that's going to be silica, or aka silicon dioxide. Let's focus on diamond. I've got these challenge questions for you to have a go at. The mega challenge question will require some knowledge on how electricity works, but I know you guys can murk this, so have a go. We clearly see that the element is carbon in diamond. The central carbon is bonded to 4 other carbon atoms. Carbon is in group 4, so all of its 4 outer shell electrons are in its 4 covalent bonds, so it doesn't have any of those free electrons that are free to move through the structure. Oh yeah, diamond has a high melting point because there are so many of these covalent bonds, so it's a lot of energy is needed to break those covalent bonds. Graphite is a little different in how it's structured. Notice that it has layers of hexagonal rings with 6 sides. And in between those layers, we have this familiar structure here. Here are some challenge questions. Come on, you know what to do with them. Graphite is also made from carbon. The carbon is bonded to 3 other carbon atoms in graphite. And as we saw, carbon is in group 4 and it has 4 outer shell electrons, but only 3 are used in the covalent bond, so that means it has 1 free electrons that can move through the structure. Remember that free electrons can also be called delocalized electrons. Graphite is used in pencil, hence the name graphite, which comes from the Greek word for right. The blue lines are weak intermolecular forces. And since graphite is arranged in layers, these layers can slide over each other. This is also why graphite is used in lubrication of machines. Because the layers slide over each other, it makes it pretty slippery and therefore reduces the friction between the parts of the machine. When you have a single layer of graphite, it becomes a special chemical called graphene. Because graphene still has those delocalized electrons and it has those strong covalent bonds there, it is both very strong and conducts electricity. This means that it can be used for phones that can actually bend and wrap around your wrist and all of that. But at the moment we can use graphene to make tennis rackets because it has a very high tensile strength, which just means that it doesn't break easily. This brings us to fullerenes, which are forms of carbon based on hexagonal rings of carbon atoms. Some may have rings of 5 or 7 atoms within them. The first fullerene that was discovered was this one here, the Buckminster fullerene, which is a spherical shaped molecule with 60 carbon atoms. This structure is called a carbon nanotube. And this is basically all the information you need to know about nanotubes.
It's simple now. Look. When I tell you to open your eyes and learn, you not listen.
They have a small diameter, and like graphite and graphene, the carbons are bonded to 3 other carbon atoms, and these are by strong covalent bonds. This gives them that high tensile strength that I was talking about, so they don't break easily. And finally, they have that one delocalized electrons that allows them to conduct electricity. Cool. We have this question now.
I'm dead. No, don't. Leave me alone, I'm dead. No, you will not die.
I hear you all complaining over there. Shut your mouth and do the work. Graphite and diamond are both forms of the element carbon. Graphite and diamond have different properties, and it shows you the different structures here. Explain why graphite is softer than diamond and why it can conduct electricity but diamond can't. Spend some time answering this question. Graphite is made up of layers that can slide over each other due to those weak intermolecular forces that we were talking about. And it contains delocalized electrons that can move through the structure. That's why it conducts electricity. Also, diamond has a 3D structure that can't slide over each other, and it doesn't have any delocalized electrons, so it can't conduct electricity. And there we go! Lessons done!
Fatality.
Check the description for the flashcards and the revision timetable. I've also added a new collection of flashcards based on the equipment that you're likely to use in science, so check those out, and I'll catch you guys in a bit.